Good morning to everyone, not only on our Zoom, but also on our Facebooks today. This is Coffee with Corn. It's a winter meeting series that's been going on since the beginning of the year, brought to you by the Corn Marketing Board of Michigan, the Corn Marketing Program of Michigan. I'm joined this morning with Jim Zook, who's the Executive Director of the Corn Marketing Program. Jim, good morning. How are you? You look warm.
You know, that's what, when you were doing the intro, that's exactly what I thought about. Our producers are probably liking these series that we have. The fact that they don't have to go outside to go to them. They can just get up, go right to their computer, and they can take in a good educational session in the morning. So I think we might have hit something, especially this week with what the weather is.
I guess so. I'm Terry Henney, farm broadcaster at WSGW Radio in Saginaw, and part of my duties, other than talking about the grain prices and some things that you should be doing in the front yard, the backyard, and out in the back 40, we do a little weather forecasting. And this is going to be a very interesting program for me, as well as I'm quite sure each and every one of you as we go through the program today, because we've got a pretty special guest, and Jim will be introducing him in just a moment. Now, the Coffee with Corn has brought a number of experts in the agricultural industry to you, to each and every one of us, because we know it is vitally important for you to know as much as you can about the business that you're in, because there are so many extenuating circumstances and so many individuals and organizations involved in agriculture. You need to understand the workings. You need to understand not only what you're doing in your field, but also what goes on with your product as it moves from harvest into consumption and where it goes. So our programs over the past several weeks, and will over the next several weeks, continue to bring all of that pertinent information to you. Now, this is being broadcast on the Michigan Corn Facebook. It's also being broadcast on WSGW, WCEN 94.5 The Moose, and the Farm Page Facebooks as well. And of course, if you want to go back and take a look at it, and I'm sure you will, as Jim and I were talking a little bit earlier, to see if we do have some forecasts here, how accurate were they? We'll be able to find that out as we take a look and see over the next several months as we talk about the weather. Now, RUP credits, CCA credits for the session, you will need to register. Hopefully you have, and attend the session on Zoom. You can register by going to micorn.org/events to get that registration taken care of. And at the end of our presentation today, you'll be able to get your credits and qualify for your credits. Again, you have to do that on the Zoom. For those of you watching us on Facebook, you won't be able to do that procedure. So kind of keep that in mind as well. Now, a lot of you I know are going to have questions. So keep those questions in mind. If you have a chance, take your cursor and right down at the bottom of your Zoom, you'll see Q&A. Might be a really good idea as you're thinking about the question to click on that. The box will come up and you can type your question in. If you're watching us on Facebook, you can do the same thing. Just go to the comments part on your Facebook, type those in. And Jim will be keeping an eye on those questions. And as we roll through the process here today, Jim will be asking our guest the pertinent questions that you have presented to him. So, Jim, first of all, before we get started with our guest, I like your pillows.
Yes, I happen to I'll be spending my time at a place in Muskegon. I came back from Florida. The wife suggested that maybe I quarantine when I come back before I come home. And so that is what I'm doing. And so it's actually worked out really well over here. So I can sit here and I can watch the ice fishermen. And it's been interesting to watch how the ice was almost totally gone as of Friday, Saturday last week. And now it's pretty well iced back over in our little area here. So as they always say, wait a little bit and you'll see the weather change.
Now, I really appreciate the gift that you sent me. Now, again, this is coffee with corn, Jim. And when you were down in Florida, I kind of thought you might send me a Tampa Bay mug, okay? Well, if our folks can read this, it says Kansas City. So I know who you were rooting for, and I do like them, but I love Tom Brady, okay?
Yep. Yeah, it was definitely a good. Well, I thought it was going to be a little closer than what it was, but it was quite a football game, that's for sure.
Well, the one thing about these professional football players, there is a science to doing well on the football field. It's physical, but it's up here too. And I guess that's the message we're trying to get to our producers today is physically, I mean, you're in it, you got the equipment to do it, but a lot of times you need that little knowledge behind. And guys like Brady, they're spending hours and hours and hours and hours studying and figuring everything out. And his methodological way of taking care of business on Sunday demonstrated a point when it comes to being prepared and get ready.
So, I look at that too, Terry, as for those of us that have a different color hairstyle than what we did 20 years ago, there's still a place for us, isn't there? That some of our wisdom really does come to play out in the future.
Well, I always use the phrase, you don't put marble on cheap furniture, okay?
Yeah. I'll remember
there you go.
One.
Remember that one, okay? It's going to come back. I know it will. Well, speaking of coming back, we had the opportunity to talk to this gentleman about a week or so ago, and now we're going to have a chance to give the floor to him. Jim, who do we have with Coffee with Corn today?
Well, so today it's our pleasure to actually bring to you Eric Snodgrass. Eric is the principal atmospheric scientist with Nutrient Ag Solutions. And so, Eric, we're going to put this on notice that this is being recorded, so we'll be able to check back to see if your future predictions come true.
You know what? That's the bad thing about Zoom meetings is that they are recorded, and as a result, there's much easier fact checking this way, right? So we'll see how well we do here this morning, and hopefully we provide some good information that just nails it right on the head. But I always tell folks when you think about long-range weather forecasting, it's speculative by nature. You're trying to predict the future behavior of a nonlinear chaotic fluid. I mean, our atmosphere, it's extremely challenging. So we'll give you the best information we got, and we'll kind of go from there. So you let me know when you want me to start, and we'll get going.
Hey, Eric, we're ready to rock. Go right ahead.
Okay. All right. I'm going to switch over and share my screen, but as I get doing this here, what I want to know is, can you see my screen and can you hear me clearly? There should be a picture of a large famous rodent on the screen right here. Can you see everything okay?
Well, I was going to say, Eric, all of a sudden your picture changed there. I thought you had glasses on.
Yeah, I don't think I've got quite the skill set of this particular animal here, but it's funny. So it was a week ago, right? Valentine's Day. That's next week. A week ago we had Groundhog's Day, and we've been celebrating this particular weather holiday for a long time, 135 years. And I decided to toss this in at the beginning because I love this time of year. Just simply because of the sequence of events, right? We go from Groundhog's Day to Super Bowl Sunday. Then after that, we have Valentine's Day. And then we get where we have March Madness and then the Masters. And that sequence of events always gets me just ready to go for spring. And so we ask the groundhog every February 2nd its opinion about the weather. Now, something that just kind of a joke here, but whatever. The groundhog has been employed for 135 years. And meteorologists always get teased about their employment because they say, you got the best job in the world because you can be wrong half the time and still keep your job. Well, just a quick reminder, the groundhog, we've continued to ask its opinion of the weather, and NOAA decided to do some statistical analysis of the groundhog's accuracy. So you want to talk about having your forecast recorded. Well, the groundhog here over 135 years has been right 38% of the time. So you actually do better flipping a coin than trusting the old groundhog. I hope to bring you a little bit higher level of intelligence in weather forecasting today than an animal that should be hibernating and probably has no idea what his shadow is other than something that's dark and you should be afraid of. And so what we're going to do today, I think, will dig a little deeper than what you got last Tuesday. All right. So let's get into this here. It was cold this morning. I pulled this off at 6:10. This was current surface temperatures across the U.S. And you can see some of the numbers there representing some of the weather stations. We had temperatures across the state of Michigan here that were, in some places down in the single digits, and go across Lake Michigan over to Wisconsin. We were seeing some brutally cold air there. Some places down -10 to -20 to -25 degrees. And this is really the first time this entire winter that we've actually seen, really cold air. And I thought we would just take a moment to talk about that, because if we would have had this interview back in October and you just said, Eric, what do you expect for this upcoming winter? I would have said, we have a La Nina that's still reaching its peak in last October, November, and December. And normally when a La Nina weather pattern, I'll explain that to you in just a few moments. Normally when a La Nina is going, we tend to just see a flow that kind of goes into the Gulf of Alaska like this and then just charges down and brings quite a bit of colder air that sweeps across the Great Lakes. And because we don't really do much to shut down Gulf of Mexico moisture transport, we tend to get an active Ohio River Valley storm track. We tend to pile up the snow across that region into Michigan. And there tends to be no shortage of lake effect snow as well. This is what I would have said would have been the case. But if you look at this map, now just take a close look here. This is the last 30 days of temperature anomalies. And if I went back the last 60 days, you'd see a whole lot more red on this map. And what it shows you is that winter did not pan out like we had expected. At least the front half of winter didn't pan out like we expected this year. Very, very mild, warm air, Pacific air that was across the Canadian prairie, at times across the lower 48. And when it did get cold, it just got cold for maybe a couple of days at best. And then we just went back over to more normal to even mild conditions throughout this winter. And there's been a couple of interesting things that happened that got us there. And I'm going to bring up that phrase that nobody likes to talk about anymore, but it's the polar vortex. And in mid-January, it had a massive disruption. You see this right here? That is not the polar vortex. This is actually a large ridge way up in the stratosphere, okay, that nudged in through Alaska into, the Arctic here. And it just took the polar vortex and elongated it and split it out such that it really stretched from the Canadian Maritimes across Europe, which is here, and then nosed into Russia. And so what happened is the polar vortex, instead of sitting on top of the planet right on the North Pole, when it was disrupted, it slid over to the European and Russian side of things. And it took all the cold air there. So Kazakhstan, Siberia, Mongolia, China, throughout the end of December through much of January, saw brutally cold air, while the pattern relaxed across the lower 48, which is here on your map. And we just didn't get that colder air in place. Now, there's a problem with that. And that problem is seen, I think, right here on this map. And I made this yesterday with the latest data that we had available. You're looking at something that shows you accumulated snowfall departure. So this is comparing to the 2008 to 2019 average, what our snowfalls look like. And you can see the colors. They kind of tell you what to expect here. These warmer colors represent where we've had less than normal snowfall, and the bluer colors represent where there's been more than normal snowfall. Now, across the state of Michigan, the lake effect snow deficit is substantial, as you can see, despite some of the great lake effect snow we've had in the last couple of days here. But the only place in Michigan that's had normal snowfall this year is just this little spot right in through there, right in the middle of the lower part of Michigan. Outside of that, we've really missed out on a lot of snow. Now, something I want to take note of, big nor'easters have really hammered Pennsylvania, New York. We've had a lot of snow down here in the southern plains. It's also been right through parts of Nebraska, cutting into southern Wisconsin. Earlier in the year, it hit Minnesota, but I want you to see this region up here. That's what we call a snow drought. parts of Montana, North and South Dakota. And I want you to think about the dryness here in a few minutes as we start talking about the latest updates in the drought monitor. And we're also going to talk about drought that's in the West in a few moments as well. But you see, our problem with the Great Lakes is without any cold air, look at this. We currently have just a shade under 20% of the lakes that are currently frozen. And the lake that's freezing over fastest, of course, is Lake Erie, which is very shallow. I'm not sure how many people on the call know this, but there are places in the middle of Lake Erie where you can take a boat out and you can not see shoreline, but a good swimmer could jump over the boat's edge, dive down and grab a handful of the bottom. And the reason why we can do that is because the middle of that lake, there are some places that are only 20 feet deep. So it's often the first lake to freeze over. But given that we could be normally about 50% frozen at this time for all of the Great Lakes, we've got a lot of open water here. Now, the polar vortex has regained its composure, I'd say. And now I'll just kind of put this in white. The main polar vortex in the stratosphere is sitting right here. No longer over Europe and Russia. It's now moved back over toward the Hudson Bay. And the disrupted polar vortex is about to, and has already begun, unleashing a lot of cold air out of the Canadian prairie that's going to be sweeping across the Great Lakes states all the way through the Ohio River Valley, eventually getting clear down to the Gulf Coast. So now that cold air has swung back from the other side of the planet, come over the North Pole. We call that cross-polar flow. And some of the cold air that's sitting right now today across the state of Michigan, 3 days ago, believe it or not, was in Siberia back on February the 4th. I guess that's more than 3 days ago. That's 5 days ago. It was back over there in Siberia. Just incredible to see that. Now, lately, we've seen the effect of this. This is just a map that went up until the evening of the 7th. That's when I pulled this one off. And it just shows you here the lake effect snow we've gotten as of late. Some places picking up 6 to 12 inches on the colder air finally blowing across those unfrozen lakes. And I grabbed just a beautiful image when it was clear mostly around the Great Lakes here on February the 7th. And you could see the bands of lake effect snow. Now, what we call the bands of snow that come like this, okay, we call these wind parallel bands coming off of Lake Michigan. These wind parallel bands can put down locally very heavy rates, but if you've ever been in those bands, you know that you could see super heavy snow over a 2 to 3 mile stretch and then get outside of it and all of a sudden it's crystal clear skies and not a whole lot is going on. It's amazing how locally they can put down so much heavy snow here. But here's something neat to know. Do you see how on the upwind side of the lakes, I'll kind of highlight it here. On the upwind side of the lakes, it's clear. You see, as the winds, the very cold winds blow across the open water, let me just take these drawings up here so I can show this to you. They come across Wisconsin and they are moving about that fast. Just let the arrow represent their speed. The moment that they get over the water with less friction, they tend to speed up a lot. And what ends up occurring here is, I'll draw this in this color, right here along that windward side, the winds accelerate near the surface and they spread out. And you actually get air to sink above that, clearing out the skies. But then you build that heat off of the lake into the lower atmosphere, building up those clouds. And when they get going, here's the magic number. If you ever want to learn about this, you need a temperature gradient in the lowest, about kilometers. So lowest 1,600 feet or so of the atmosphere. We need it to be around 13 degrees Celsius. In other words, if it drops off that dramatically, the lake can really transfer its heat quickly into the lower atmosphere and produce, look at these hyper-local lake effect snowstorms. Now, if you've never seen this in time lapse, now this is from Buffalo, but it's still a great view of what these lake effect snow bands look like as they just transfer that heat and moisture off the lake and then deposit it in these heavy bands just downwind of the lakes. What a beautiful thing to witness. And our Great Lakes play host to some of the best lake effect snow on the planet. And you know what happens when it really gets going. So with that in the backdrop, knowing that the lakes are unfrozen largely, and there's plenty of cold air coming, we are going to be watching out for some more lake effect snow in the coming days and weeks. But in the near term, all the story is going to be around two areas. It's actually going to be south of us here. We're expecting not only a lot of snow in that area, but ice and a bunch of other nasty stuff. In fact, right after I'm done talking to you today, I got to go talk to a group in Indiana and talk to them about the ice that's coming there into Indiana and Kentucky and Southern Illinois. What we're dealing with, these colors that you see here, well, north of that line right there, this is all wind chill warning in this area, and these are wind chill advisories. And this cold air that's coming down is going to be with us for quite some time. First, let's at least get a good glimpse of what we're expecting in terms of snow. And this just takes us out through this upcoming weekend. And what you can see here is that the action is going to be south of us on the big winter storms, but we do expect to get some lake effect snow in the range of possibly 2 to maybe 8 inches when you get right up next to the lakes, but without any major winter storm systems expected in the next few days to come through. You get down there toward Ann Arbor in that region, we're not expecting major snows in this area. So it's going to be primarily lake effect coming off of the cold air blowing across the lakes. Now that's your near term kind of snowfall forecast. But I got to show you these temperatures. Are you ready for this? I hope this plays nice and clearly for you. Today's highs going to struggle to get out of the teens. This is a map where the numbers tell you the forecast high, but the color shading, which you see over here on the color bar on the right, tells you the departure from normal. And you are going to see how effective the Rocky Mountains are at channeling this cold air south. You ready for this? So this is today on Tuesday. This is how things shape up on Wednesday. Then we go into Thursday. Look at this. Ready? Toward the end of this week, Friday, Saturday, and Sunday. I think Sunday will be the greatest depth of cold getting all the way down to the Gulf of Mexico. We stay in the single digits and teens for high temperatures, but look at how cold this area is coming through the southern plains. We expect 4-inch soil temperatures by next Monday to be sub-freezing all the way down to almost the Gulf of Mexico, including the lower Mississippi River Valley and Texas. And why that's important is, believe it or not, we've already got planters rolling in southern Texas to get the corn crop going. That's right, they're already starting to plant the crop down here in southern Texas. It's not much acreage, but that's what's going on. So some brutally cold air is coming in as we work our way through the next several days. We do have the benefit of the lakes moderating the temperatures just a bit over what our neighboring states are getting here. But how long is it going to last? Well, this map takes you all the way up to February the 19th. You can see the storehouse of colder air continuing to just unleash that as the polar vortex stays fully disrupted here through the middle of the month of February. Should we expect moderation toward the end of the month? There are some indications that that could happen, where the colder air retreats back up into northern Canada and Alaska, and maybe some more mild Pacific air comes in at times. But it's not as though we're going to return back to the very warm time periods that we've been having back in, for example, December and early January. But I'm going to get to that spring forecast in just a few moments, because in order to understand how we're going to get into that long range perspective, I'd like to at least just take a step back and tell you what's really controlling the background flow of the atmosphere, okay? So we have had since mid-July a developing La Nina. Now, La Ninas and El Ninos happen right here in the equatorial Pacific Ocean. And as I animate this, and I hope it plays smoothly for you, but it's every single day from July 1st through mid-January. And you see the blue colors that are showing up there inside of that oval I drew? That is the developing La Nina. And I stopped this on January 16th because this was the peak of this current La Nina event. And it has since been fading. And that is going to be a major discussion point as we work our way through what this longer range forecast is going to be. Now, how about we just do a little bit of meteorology 101 here? If I was a farmer in the Midwest, in the Great Lakes states, and I had to think about the relationship that I'm going to have with El Nino or La Nina, I'll tell you this, I'm going to prefer El Nino. You see, El Ninos occur when there's warm water coming off the equatorial Pacific Ocean, in the equatorial Pacific, off of South America. And when that occurs, the trade winds slacken, and we tend to see increased moisture over both North and South America. On the flip side, La Nina events tend to give us very strong trade winds that shove a lot of cold water off the west coast of South America and take all of the increased rainfall activity over to Australia, Indonesia, and Southeast Asia. We've been keeping track of El Ninos and La Ninas for over 70 years. And just to let you know something, we actually can't use this time series to predict the next one. Our time horizon on really witnessing or predicting a La Nina or El Nino is generally about 6 months at best. I trust it inside about 3 months. And here's what I want you to see. The current La Nina is right down here at moderate strength. and it is rebounding back toward neutral conditions over the next several months. I'll show you that in a few moments. The last time we had a La Nina like this was back in 2010 and 2011. And that La Nina rebounded, but then came back down for kind of a second surge in 11 and 12 before going back toward neutral conditions. It then built into a big El Nino several years later in 2015, 2016, which on record is the strongest El Nino that we've seen. So we had better talk about what this La Nina can do. And it begins with this map. Ready? If I were teaching a bunch of sixth graders about La Nina, I would want them to take home this to tell mom and dad. You see, we live in a pocket where the winds come out of the west, a place on earth where the winds come out of the west. We call them the westerlies. It's our jet stream winds. What La Ninas tend to do, and this is what I want them to tell folks, is that La Ninas rob the jet stream of its westward momentum. They slow it down. La Ninas let it get blocked up into big ridges where a lot of heat and warmth can build to the north, or deep troughs where it gets established into cold air for a while. That's what we mean by a blocked pattern, where it sticks around for 10 plus days and doesn't get out of its own phase that it's currently in. El Ninos, the jet stream screams, just blazing across the North Pacific, through North America into the North Atlantic, more zonal, more west to east. And I'll tell you something, if I was teaching sixth graders in California, I would tell them, you want El Nino winters every winter because they increase your chances of getting precipitation. And you're going to see in a few minutes, California's missed out on this big time. They missed out on it all summer. This map here shows you last year, January 1st to December 31st. And there's a number inside of every climate reporting district. Now, across the United States, there's 129 years worth of data. And the closer your number in your climate reporting district is to the number 1, that would have been the wettest year on record. 129 would be the driest. Look at how dry the West was. Look at how wet the Southeast was. And in the midsection of the country here, we're going to talk in a few minutes about what we experienced with flash drought and flash flooding. Let's start west, though, in case you didn't see this past year. The ridge in the middle of summer backed up over the Four Corners states. And I want you to remember that ridge over the Four Corners states, because what it did was it set up a ring of fire pattern where the flow came over the top of it and went straight across the Great Lakes. That was our source of summer thunderstorm activity. But it really robbed the West of getting any moisture return, and it lit the place up, literally and figuratively. 8.2 million acres were burned. We had dry thunderstorms, routine dry thunderstorms almost every day. Dry thunderstorms put down rain, but it never gets to the surface. But you know what makes it to the surface? The lightning strikes, and it lit up a lot of fires. This animation here was on September the 6th into September the 7th. That was Labor Day weekend. And I'd like to show you this fire right here in Colorado, because that fire, the Cameron Peak fire, produced smoke that went across Kansas, it went across Nebraska, went into Iowa, Illinois, and we saw smoke deep in the stratosphere from this fire in the state of Michigan. It got really, really deep, but it was there. I'll show you an animation of this. This was back when the Cameron Peak fire was still going in October. And the colors you see here, which just spread across Michigan on their way to the North Atlantic, that was the smoke from the Cameron Peak fire. By the way, we saw smoke. Again, the Cameron Peak fire was here. We found smoke from this that not only came across Michigan, then dove south, but we found it 5,000 miles away in the North Atlantic. It was an incredible year. And if you've never seen smoke like this, I would like to take you quickly to San Francisco, because on Labor Day weekend, when the winds came out of the east and blew across San Francisco, what we ended up getting here was basically blotting out the sun's light. In midday, we were only getting some of the red and some of the orange light coming through the atmosphere. It was enough to dim it down to just turn on the street lamps. Incredible to see that. On the flip side, I'm going to circle for you in white Bermuda. But this, where I'm putting the H, is the Bermuda High. It slid a little bit to the east, and the flow around it just opened up a wide corridor of winds that were allowing, well, a record number of tropical cyclones to hit the United States. We flew into all of them. And this is a map where each line here shows you a different transect that the hurricane hunters flew through one of the record number of tropical cyclones we had this year. There were 30 of them. And this, here at the end of October, is Laura. Now, Hurricane Laura was likely the worst of all of the tropical cyclones to hit the United States. We had a dozen tropical systems that either brushed by or made direct landfall in the US. When Hurricane Laura went through here, let me show you something. It destroyed the radar in Lake Charles, Louisiana. Normally on top of that pedestal, there's a radome that goes around a big 30-foot wide dish. And this is one of our S-band radars we use to monitor precipitation. Well, Laura, in the middle of the season here, was just one of the 30 named tropical cyclones. And speaking of middle of season, I'll underline the date in the upper left-hand corner. That's the peak of hurricane season, mid-September. And we were already, well, you can see the letters, right? Sally, Paulette, Renee, Teddy, Vicky. We had almost completely run out of our names by the middle of the season. So our contingency plan was to go into the Greek alphabet. And I'd like to show you Hurricane Epsilon. You're going to fly through it here with the Hurricane Hunter. You're going to come through the eye wall here in just a few moments at 10,000 feet, and there you go. That's an eye wall penetration. We're about to take this Hurricane Hunter right to the center of this circulation, drop an instrument pack so we can forecast where it is going to go. Now, when I put all that together, let me just show you where all of these 12 separate tropical systems that either brushed by or the 10 of them that actually made landfall in the United States went. Now, with the West baking and the Southwest flooding, the Midwest and the Great Lake Basin was caught right in between. And I'd like to talk to you about what we had to do with in the Midwest in the primary corn and soybean belts. We're going to take a broad view of this, and I'm going to give you just a quick lesson about flash drought. Now, the maps we're going to be looking at here are 4-inch soil moisture maps, and they start on the 15th of July and go through January. And what you're looking at here is going to be a percentage. So this is the percent saturated. So you can see the color bar on the bottom. Now, as I get this playing, what we noticed was that throughout much of July, we actually had quite a bit of thunderstorm activity that went from Wisconsin across Lake Michigan into Michigan. But southern Michigan, northern Indiana, and northern Ohio at times got quite dry this summer. For example, this is July 30th. Look at the dryness we were seeing down here in the southern part of the state where our soil moisture values at 4 inches were under 10%. But as we move throughout the month of August, storms returned here, but not back in Nebraska, in Iowa, and parts of northern Illinois. This is about the time where we were seeing very, very dry conditions, despite a big derecho event that went through, starting to build across, well, let me show it to you here. How about we just stop it here on August the 20th? Pennsylvania, northern Ohio, northern Indiana, look at Michigan, northern Illinois, Iowa, Nebraska, South Dakota, such that if I keep this going toward the end of August, let's just stop it on the 27th there. Widespread flash drought developing in under a month here, right across this section of the Corn Belt. Iowa, third driest August on record. Illinois, 13th. Nebraska, driest. What made Michigan not in the top 10 was because of all the rain included here in the northern part of the state and the UP, which goes into your statistics, but very, very dry in the southern part of this. Now, we did have on Labor Day weekend a big system that came through. But look at what happened here. Let me get you to September 13th. Are you ready for this? The end of the growing season got extremely dry again. Here we are into October. Let's just pause it right there, October the 11th. Look at how dry things were. While the Southeast saw hurricanes, the Southwest saw drought, and the midsection of the country went very, very dry for our harvest. All of this was punctuated by that derecho event. And just taking you again back to the West to show you this event. On August the 10th, storms born out of South Dakota and eastern Nebraska raced right here, as you're going to see it, through parts of Iowa. Those storms then spread into southern Wisconsin and Illinois and eventually hit Indiana and went through southern Michigan, still producing damaging winds. But the bulk of the damaging winds from this event hit Iowa. And right on Cedar Rapids here, you can see what 80 to 130 mile an hour wind gusts did. The infrastructure that was destroyed and the corn and soybean crops that were laid flat. Well, when I went and did a satellite estimation of this, the first Saturday after the duration, we had some clear skies, I was able to identify 8.5 million acres of damaged corn and soybeans. But some recent estimates put this at something up close to 14 million acres that were damaged or destroyed. And I believe the current cost of this is estimated to be around $10 billion. Now, derecho events like this are, believe it or not, more common than you think. On average, the return time period for one of these in the Midwest, and that cuts over to the Great Lakes Basin, is about 1 in every 7 years. So they do happen quite frequently. But remember, even though that derecho went through, we got dry again as we went into harvest. And just to show you a couple of pictures of how dry it was, my home state of Illinois, you can see right here, my friend Chad Colby was out flying his Cessna, and he went out and saw a picture here of a burn scar across these fields in Illinois. And over in southeastern South Dakota, a field fire on that drought raced through those fields, burning off everything, leaving just some of the stalk and some of the corn there. Now, it's been a great point here. I got to teach my children that when you burn field corn, it doesn't pop, but the guy did decide to harvest it and reported back to us that he did get it in at 3% moisture. Okay, from there, let's now get back into the bigger picture things. That was our review of 2020. 60% of the country's in drought. And there's a region that stretches from central Illinois into parts of southern Michigan that are actually still in the first and second stage of drought as well. But do you remember earlier when I was talking about the northern plains? This is something that we got to watch carefully, because northern plains drought, upper Midwest drought, cannot be cured during winter. It's going to be there until spring. One thing that I want to watch very, very carefully is how that drought evolves by the time we get into May. If it is still there, why I'm concerned is that drought in that particular region can sometimes in summer get the jet stream to run right over the top of it. And here's a quick bullet point that I'm going to come back over in a few minutes. If we end up building a ridge, I'll put an H over it, that sits right here in northern Minnesota, right on the arrowhead, that is a situation that tends to build drought across the Great Lakes Basin and bring in a lot of heat. And I want to watch that carefully, because it may begin to the west and migrate to the east with time. But 60% of the country, that's in drought. Now, when we think about weather forecasting, because now we're going to get into that long-range forecast as I start to wrap this up, I want you to remember that the bulk of weather forecasting is done with numerical weather prediction. Back at the end of January, our numerical weather models did a phenomenal job here of forecasting a severe weather event over the southeast. I know this isn't Michigan, but over the southeast. To show you that the usefulness of these models, I just want to remind you of a quick story here. When that particular storm system went through northern Alabama, it produced a tornado. And there was a young man here sleeping with his wife and their baby in the play yard here when his NOAA weather radio went off, and he took his family to shelter. We've been forecasting the potential for severe weather in his area for 4 days before it occurred. But the immediacy of that NOAA weather radio told him to wake up and get to shelter. And not a few moments later, a 2x6 came through the wall and went right to where his wife was sleeping. So these weather forecast models are critical to our ability to predict the future weather. And there are two of them that outperform all the rest. One group of models is run here in the United States, the National Centers for Environmental Prediction. Their flagship model is called the GFS. The Europeans, which is the models I showed you earlier about your snow, have a superior modeling system. It's been better than what we've got in the US for the last decade. And what I want you to think about when you think about these weather forecasts are, how do you use them? Now, to explain that, I want you to see this graphic. We'll skip that one and get right here. This one shows you that with forecast lead time, how the forecast skill changes. I got asked 2 weeks ago by a farmer, okay, I love your information. It's great. How do I use it? I said, my weather forecast information, which comes from these models, use it to plan your operations over the next week. Use it to think about what operations are going to look like into week 2. Use it to make decisions about when you're going to spray, when you're going to plant, when you're going to harvest, when you're going to apply. Use it to go out after we forecast and before we forecast to look at what your field conditions are so that you can continually assess throughout the season how things are going. But you must remember that forecast skill drops off dramatically with time. And research has proven that an accurate day-by-day weather forecast beyond about day 20 will never be a reality. Even with the most sophisticated weather modeling and the highest resolution data sets you can imagine, the fact that the atmosphere behaves as a non-linear and chaotic fluid means that it has limits of predictability. And as a consequence of that, to give you an accurate day-by-day forecast from day 20 and beyond will never, ever be a reality. What we are going to get better at is telling you the probability of being above average or below average with precipitation or temperature. And that probability is going to get better and better and better at accuracy and with skill. And that's what I do. I spend my days researching that one thing. So let me show you what we've got. Through middle of March, the likelihood of keeping some cold air around is relatively high. It's going to be coldest for the next 10 days and start to back off. But through possibly the middle of March, we are, let's call it the beginning of March, any sort of relief where we bring in much above average temperatures again isn't in the works. We do expect the Pacific Northwest, we expect the Great Lakes Basin and the Ohio River Valley to have a lot of precipitation. What I'm concerned about is California, the southern plains stretching clear up into southern Alberta, Saskatchewan, and Manitoba. Those are areas where we already have drought. And if by mid-March we're not correcting some of that drought, there's concern. Now, I want you to remember something. This is going to feel more like a normal winter. We've had a very mild winter up until the colder outbreak we've just had. But the question is, how long does this last and what does it mean for spring? So I've given you that mid-February through mid-March outlook, knowing that the coldest is going to be in the near term. But take a look at this. The week of the spring equinox, the models are really trying to back the coldest air west. See it? And they're trying to keep those active corridors, as I highlighted there a few moments ago, continuing to stay active. Now, I would want nothing more than above average precipitation here going into the end of March. And there's some indications of that. I don't like how dry they're trying to keep the southern plains backing over here toward California. That would mean that the drought in those regions does not have much of a chance of being relieved through March. And the Californians are desperate for what they call a miracle March, which brings in all of the moisture that they've missed out on so far this year. That's through the spring equinox. From there, we have to talk about our fading La Nina. Now remember, the strong trade winds are still in place here, and our La Nina is still going. It's still kicking here in the Central Pacific, and it'll be there for a while. But I want all of your attention right in through here, and I'll just draw a line through it. I'll make it white, right in through this area. Now, why, between those two parallel lines and that white line I drew, do I want your attention? You see, when we think historically about what impacts the heat and dryness that we can get in summer over the Midwest and the Great Plains and the Great Lakes Basin, there's a strong correlation between ocean temperatures, where I'm coloring in here with white, and that area. So these two regions are linked, and I want to show you why. Right now, the forecast for March, April, and May, can you see this? Has some cooler water in this area with a warm tongue here and a warm tongue of water in the North Atlantic. This down here is our fading La Nina event through this spring. Now remember, of all of the different things that can control your weather, oftentimes the biggest controls the background state, and the biggest event will be this La Nina as it begins to fade. So we have to come back to our initial question. Are we going to improve this drought situation? And now as I start to wrap this up, let's talk about it, okay? This was just released on Friday. Right now, the long range outlook for, and the time period here is March, April, and May, is for there to be increased precipitation in the upper Midwest and Great Lakes Basin. Drier conditions here, where I'm putting the D over the four corner states of the Southern Plains, and potentially drier conditions along the Gulf Coast. Wet in the Northwest, but possibly not getting down into California like they need. The cold air that's coming in now seems to be relieved as we work our way into March. And what we see here is mild conditions are currently forecast. Now, remember something, when you see this, don't let your mind go floating back to hoping for 80-degree weather in March. That's not what I'm talking about. This is indicating that the chances of the sustained cold air, I'm talking about sustained cold air through our spring right now, has been consistently forecast to be of minimal threat. It doesn't mean we can't get cold air in March, April, or May. That can happen. But sustained, really cold air is right now of low probability. Make sure you heard me clearly with that. There's support from other models as well. These were just released yesterday. It is the March, April, May. See that, ma'am? March, April, May forecast from what's called the NMME, where, as I just showed you, the European model run in Europe, the N in NMME stands for National Multi-Model Ensemble. You see how it is also wet in the upper Midwest and Great Lakes Basin and dry over the Gulf Coast and dry back here in the high plains. It too has warmer conditions. Now, please, when you look at this, don't go, holy cow, it's going to torch us here through the next 3 months. Do you see the color bar down here? That's a 3-degree above average temperature color, right? So this is not as though we're going to be hot. It's just suggesting that the mild end of winter, start of spring could be there. Now, what this has got me thinking is if we return moisture and the temperatures are mild, we can get that moisture into the soil. 1. 2, that alleviates some drought issues. 3, when the window opens up, we had better be ready to crank and get this crop in early. We know the benefits of getting a crop in early if we don't have the risk of a late frost. And there is not a soul on the face of the earth in February that can tell you the risk of a late frost in mid-May. We can't do that. We can only forecast that about 5 to 10 days in advance. But what I can tell you is that this particular situation is one that inside of the arc I just drew there, we have increased risk of severe storms in spring. I want to watch out for that because fading La Niñas tend to give us high rate of severe storms. Now, it's especially down here in parts of the Mid-South and Lower Mississippi River Valley, but it's much higher than normal too across Wisconsin, Michigan, and the rest of the Ohio River Valley and Great Lakes Basin. So in addition to that warm up, we do need to be concerned about early severe weather in spring. Now, I came back to a point a few moments ago where I was looking at the risk of those colder waters. And this is why. Remember earlier when I said I don't like the drought that's in the northern plains? Here's the reason. If the jet stream takes on a path, look at the drawing over there on the right, that builds into ridge between the UP and Minnesota and Ontario, Manitoba. If a ridge is established there by summer, which it did in these years, you see right down here, we are blocked from Gulf moisture. The heat sticks around, it builds under a large dome and it gets dry. So why I've been talking about those ocean temperatures, look over here on the right. Those same hot, dry summers listed right here had colder water, I'll just kind of draw it for you, off the Baja of California, extending into the Gulf of Alaska. That is one of the lead indicators that we run the risk of drought conditions here. What about the opposite? If there's warmer water in this area, we tend to make a big ridge over British Columbia and the jet stream ridges out there and then dives into a trough across the Great Lakes. And we have our best yielding summers when that occurs. So it's all about finding that ridge, and the ocean temperatures are a precursor to it. So thinking about that, what's happening May, June, and July? At this point, there are near normal water temperatures in this area. And there's a warm tongue of water here, and the La Nina is down here, stretching from South America to the Central Pacific. The fact that there are near normal water temperatures in this area, if properly forecast, increases the threat of drought in the northern plains and in the Great Lakes Basin for winter. But it doesn't guarantee it. It just increases it right now. Looking beyond that, this is the latest update from the long-range models. Now, can you just write down in your notes, 0, 0. These models historically exhibit 0 skill out forecasting a 6-month time period. But do you notice how currently they're favoring drier conditions? That's the European. This is the NMME. The number one question that will be asked as we get into May and June will be this. Ready? I'll take these drawings off here. Will the ridge be here or will it be here? That's going to be the difference maker for the Great Lakes. Historically, over the last 30 years, the ridge has backed to the west or retrograded in summer. And when that occurs, what we end up getting, I'll kind of draw this in blue here, is flow that comes over it and targets us with the perfectly timed summer rains. But occasionally the ridge does, and we'll draw this over here in red, it comes back over to this area. Now I'm going to make a point here as we start to wrap this up. My ability to forecast that, or anybody's ability to forecast that now in February, is non-existent. We can't do it. I'm telling you what we have to watch for. I want to know what the drought monitor looks like May 24th. When it's released at that week of May, it'll then tell me what risk I'm going to see for June. And once I see the June risk, we can start to make some conclusions about July. But for the primary corn and soybean belts, I think we might buck some of the longer trend when it comes to looking at what controls the county level production and then the variance on that county level production. What I'm specifically talking about here is this. For the primary corn and soybean belt, and that includes Michigan to Ohio, all the way to Kansas, north to North Dakota. For that whole region, over the last 70 years, look at this trend. This is critical. We've increased rainfall by 5.5 inches. Unfortunately, those increases in rainfall are met with high variability. We still have years like 2012, like 1988, 2005, 1976, where it can get really, really dry. You got to move the ridge over Minnesota. But what is most concerning to me is some new research I've been doing for Nutrien. And for the state of Michigan, I went back and plotted every year since 1981 and then put a trend line on it, which I'm drawing for you here, all right? That shows you your trend in heavy rainfall events. You've nearly doubled over the last 40 years the frequency of these very heavy rainfall events, defined as more than 2 inches of rainfall a day, which means our rainfall is coming in bigger and bigger helpings. So where I'll finish, and we can certainly take some questions about South America in a few moments, where I'll finish is with this. When you think about the long-term success of farming here in the state of Michigan and the Great Lakes Basin, water management is going to be key. The more we do to take care of our soil and its health, the better able we are to resist the influences of drought and flash drought and the abundance of rain when it comes. We've got to have good soil management practices to handle what the atmosphere is going to give us. And I want to think about that as a bigger picture theme as we move forward here, because there's some uncertainty about 2021 as it's approaching. And I've presented to you some long-term statistics. You know the risks that are associated with those colder ocean temperatures, but you also know the longer-term trend is to keep the heat west. What we have to watch out for here is the transition into spring and what it means for the risk of our upcoming summer. And with that, I've got about 7:55 on my calendar here, Central Time. I think we could open it up to questions, and I'm more than happy to talk about South America too. We can get to that, but I wanted to get to some questions here for you. So I'll turn it back over to you, and we can get to that.
Jim, do we have any questions from anyone yet?
Not yet, Terry, but Eric, I just want to tell you that I've had some texts from some people, and this is probably by far the most engaging, or I should say educational series that we've had. It's been, I think most of us are like a sponge. I'm very glad that we actually recorded this, because I'm going to have to go back in and actually kind of follow the El Nino, La Nino type of thing through. Maybe one of the questions that I've got is, you know, we're talking about the new administration, carbon, warming, trying to reduce that. How much of that affects our weather, especially since it's starting out into the oceans, and that's kind of where it stems from?
Yeah, that's an excellent question. Let me give you some of the data we have collected and try to understand it. You talk about the oceans. One of the reasons why the Midwest, the Great Lakes Basin, has seen an increased level of precipitation and a lowering of the frequency of big drought events like those of 2012, 1988, those kind of events, has largely been because the North Pacific Ocean has, over the last 70 years, seen a major increase in its upper ocean heat content. The warmer you make the North Pacific, the warmer you make the Western United States. The warmer you make the Western United States in summer, the greater the frequency of their drought and their heat. We are downstream of that. We end up getting better conditions with cooler weather. If I could show you some long-term statistics for the state of Michigan, when you think about your temperatures here, one of the things that we have witnessed in the state of Michigan, just as an example here, is actually our prevalence of extreme heat during the day in the middle of summer has actually been decreasing. It's been going down with time. While I'm saying all this to you, I'm trying to pull this up so I can actually show you the data here, but it's been decreasing with time. And because of that, it's really at a consequence of what's been going on in the western part of the United States. They've been taking on more of the heat than we have here in the Midwest. So I'm going to show you, let's see if I can get this to pull up here. This is going to be for the state of Michigan, June, July, and August. Okay, I got it here. Let me just share my screen again so you can see it. Whoops, there we go.
And while you're bringing that up, Eric, there is a poll we'd like for you to answer that's on your screen or at the bottom there. Pull it up. Please take a look at that poll and answer the questions that we have. So go ahead, Eric.
Yeah, so this graphic you're looking at here is June, July, and August. So we're just talking about summer for the state of Michigan, going back over 70 years. You see that blue line there? That's your trend line. We have seen just a very, very small incremental increase in our maximum temperatures, which means while we can still get hot, the frequency of those high heat events is nowhere near as high as it is in the western part of the United States. Where we are seeing the biggest changes, are you ready for this, is in our minimum temperatures. I'm now going to plot for you summer minimum temperatures. And since 1948, we've seen almost a 3-degree increase. Can you see it there? In our minimum temperatures. And that actually holds true back in spring as well. This is what's allowing us to plant a crop earlier and earlier, this change in our local climate in the state of Michigan toward warmer springs with warmer overnight lows, yet we're resisting the extreme heat that the West is enduring. If I did the same thing, but instead showed you California, and we looked at those maximum temperatures again, now this is for the state of California, look at their upward trend. And that is, well, if they're taking on all the heat, we are not here in the Midwest. And that is just the way the climate is changing here across the state of Michigan. So that's it. There are the data right in front of you there. That's what I wanted to share with you with regard to that question. And it's an excellent question there.
So I think what we're looking at too, just real quick, I think what we're looking at too, Eric, is again, the function of the lakes when it comes to our daytime temperatures. There is some form of moderation there.
Absolutely. Yeah. I mean, you think about the specific heat of water being 5 times greater than that of soil. So that means it takes 5 times the amount of energy to change water 1 degree than it does soil. So you get that wind coming across the lakes, and it's just this beautiful, great moderator allowing for the climate of Michigan. Well, that's why people want a vacation there, because we want to get out of Illinois. We want to come north and get into your nice moderate summers. And it's because of what the lakes can do. You're 100% right.
Okay, Jim, more questions?
Yes, we do. So we have another question, and the question is, how does the Midwest weather compare to South America weather with respect to La Nina and El Nino?
Yeah, let's do that. I'll go back to sharing my screen here. Let me click on this again. And the question is about Midwest weather versus South American weather. And I'm going to come down to South America here. I'll pull this up in full screen. Okay, Midwest weather is very similar to what they have in Argentina, which is down here. Argentina's main growing areas between Cordoba, Buenos Aires, and a little place called Santa Fe. Not little, but a place called Santa Fe. This little triangle I'm drawing with the mouse, that's their breadbasket. That's their Midwest. Okay. They have similar soils to us. They have westerly winds, same as we do, and a big mountain chain to their west, which is the Andes. It's very similar to here. But Brazil has a weather pattern that's dominated by a monsoon, entirely different. They have an extended dry season, that lasts during our summer, their winter, and then it rains like mad from, well, really November through April. And I want to remind you of something here. Brazil currently only farms about 8% of its arable land, all right? And they're every year adding sometimes 1 million to 4 million acres. Unlike what you've been told, most of that acreage comes from pasture land conversion down here. They no longer burn into the rainforest like they did, like was done back in the 70s and 80s. They understand, the farmers down there understand clearly that to preserve the integrity of the rainforest is essential to their monsoon. Okay, Mato Grosso, the biggest producing state, which I put Texas inside of here, grows 30% of their corn and soybeans. They grow the equivalent of an Illinois and Iowa soybean crop. But here's some research I want you to know. So you ask about the weather comparisons. We've been watching over the last 40 years that Brazil's dry season has been getting drier. And this is tightening up their windows to plant the first crop soybeans and then harvest it and plant the safrinha crop of corn. Now this year, it was the driest on record. That's the bottom line here, driest on record for Mato Grosso. And they've continued to be dry while southern Brazil and Argentina have lately seen some wetter conditions. And that's why when you look at their soil moisture, look at Brazil's northern and eastern growing areas versus their southern and Argentina, which has got much more moisture in it. So southern Brazil, about 50% of the crop is grown here, is covering for the deficits in northern and eastern Brazil. Okay, harvest pace, they're way off harvest pace. They're about 25% behind where they should be. And that's because the crop went in so late due to the drought that lasted longer into the month of October. That's what you've got going here. But what I want to show you is this. The La Nina, you asked this question about La Nina. The La Nina tends to favor, at the end of the growing season, drier conditions south in Argentina. And this map shows you from now all the way to March 21st that we're worried about drought risk developing in the Midwest of Argentina. Got it? And therefore, we're going to pay close attention to what happens down here. While as they're trying to harvest the first crop of soybeans and plant the second crop of corn or safrinha crop, there is going to be risk of too much rain, further delaying the harvest in some areas. Not all areas, but some areas. And eastern Brazil is supposed to go over very, very wet throughout the next month. That's what I've got for South America right now. And it's going to continue to put a premium in the markets down there.
So another question that we have, seems like we're getting more frost-free days per year in Michigan.
Sure.
While our total precipitation is increasing. Does this do anything to weather predictability, more or less predictable?
Yes, it does. And I'm going to try to show you here a figure I made, or a figure I borrowed that kind of addresses that issue. I wonder if I've got it. I think I may have presented it back in December. Oh, shoot. But the answer to that question is, yeah, you've increased your frost-free days by about 9 days. I think it was in this talk I gave at Purdue. Let me just run down here and see if I can find it at the bottom of this one. I'm sorry to have to fly through slides like this for you. But anyways, I'm telling you, the increase in your frost-free days is to the tune of about 9 days. Ah, there it is. Perfect. So take a look. So you see here the upper Midwest, this comes from the US Climate Assessment. We've added about 9 days. And the graphic over here on the right shows you the deviation from average on our length of our frost-free season. And you can see that since the 70s, we've been increasing it to an average of in the eastern part of the country of about 9 days. It's much greater to the west here. So the anecdotal evidence you just shared with me, this is an article from the EPA. This just backs up other research that we've been doing that illustrates that same point. Does it make weather predictability more difficult? It makes farming more difficult, believe it or not, because even though you have this change where you'd want to plant earlier and earlier, right? Where you'd want to plant earlier and earlier, we still run the risk like we had last year of that big frost event that hit us in May. And that can still happen. And that's something that we got to be on the lookout for. Excellent question.
So I think where we're really seeing it too, Eric, is in nurserymen. Nurseries are big in Michigan. And
Sure.
I've had numerous nurserymen tell me that they're looking at us being maybe 1 or 2 zones warmer than what we were about 10, 15 years ago. And some of the plants that they're able to sell folks are much more common maybe 20 years ago down in Tennessee or in Alabama, in those states. So I think your nighttime readings are dead on when it comes to some of those things. And yes, it does. It does cause us to think maybe more than once about putting crops in a little bit earlier. But yeah, we're always going to have that threat.
Yep.
As long as we keep our water warm in the lakes, that threat does go down a little bit.
So one last question, Eric. How much does the ice cover on our Great Lakes affect our spring temps and maybe even spring precipitation, some of those things?
Well, I studied, and I apologize, I'm not going to be able to pull up the figure here, but I studied the effect of the ice cover over the Great Lakes in Michigan's spring temperatures. And I'll be honest with you, it's about the only state that has a relationship that's got some statistical significance to it. So in other words, this doesn't apply to Wisconsin, this doesn't apply to Indiana or Ohio as much as it does to Michigan. But the correlation between ice cover and your spring temperatures is about 0.4. What that means is the greater the ice cover, it's actually negative 0.4, the cooler your spring is going to be. But it's not a guarantee. We've had springs where the blast of warmth comes in. It just doesn't even matter what the lakes are doing. There's plenty of warmth in place that it can overcome some of the issues with the ice coverage. At this point, the duration of the cold air for the next 15 days, we need to see by the time we get to, let's call it the end of February. Did we get past 50% on lake ice coverage? If we didn't, and in March does come in with more mild conditions, I'm not cold, not warm, but just mild, we will have a better chance at having warmer weather in spring because the lakes just aren't going to be having to overcome the melting of the ice and then the sensible cooling of the water, sensible warming of the water, which could prolong winter's effects. So I think by the end of February, we need to take a close look and see how close we are to 50%. If we're at 40% or less, that is, based on the statistics, like I told you, a better chance at us having a more mild spring.
Well, with that, Eric, I want to appreciate your time this morning.
Thank you.
This is definitely very enlightening. I'm sure our growers found this very interesting, and they're probably scratching their head saying, what do I do now? So with that, thanks, Eric, for joining us today.
Thank you.
How about long day corn, Eric? What do you think?
You mean putting in your racehorse and going after it this year?
There you go.
Don't ask me that question. I don't have an answer. We chase yield, right? I mean, that's we want to. That the bigger and better of a crop we can grow, knowing the soils we have and what the climate can give us. This year, I hate to say this because I am not a person that gives into speculation, but I have increased concern about drought this year more than any other year in the past. And I'm going to tell it to you as plain as day. I have never been more hopeful that I am wrong than my entire career. I hope I'm as wrong as can be.
Well, Eric, we really appreciate your information. As Jim said, we're going to take this to heart as we move through the next 90 days here and get a real good idea of exactly what our weather is looking like, given the information that you've given us, where it's not a matter of, okay, is it going to rain tomorrow? It's a matter of what are some of the determining factors that go into possibly making it rain tomorrow. We really appreciate your insight.
Thank you. Have a good one, everyone. Thank you.